Hypothesis testing involving one population, Chapter 11.4 and 11.5. Let's review what we've seen so far in hypothesis testing. The purpose of hypothesis testing is to see if sample data is strong enough to reject a null hypothesis. The null hypothesis represents a current belief, the status quo, regarding a population parameter, like a population mean. In future hypothesis tests, we're going to see a test for population parameters like the population proportion. We've studied hypothesis test problems that provide a population standard deviation, which is symbolically known as sigma. We will now study hypothesis test problems that provide a sample standard deviation. So instead of being given sigma, we'll be given S, the sample standard deviation. When constructing confidence intervals, so this is from our last chapter, in which the sample standard deviation was given instead of the population standard deviation, we used t-scores instead of z-scores, and the distribution was a t-distribution instead of a normal distribution. So you should remember that this was the type of problem where you had to go to the chart and find the t-score from the chart using a degree of freedom and a specific confidence level. That's the t-distribution, and it's used when you don't have the population standard deviation. The same case applies here. With hypothesis testing, when the problem does not provide a population standard deviation but gives us a sample standard deviation, we will use the t-distribution. So there is a part of the hypothesis testing procedure where you are asked which distribution you're going to use, either the normal distribution or the t-distribution. In today's lecture, every example is going to make use of the t-distribution. Using the t-distribution, recall that a p-value, which is a probability value, is the area to the left of the sample statistic if the test is on the left, or it's the area to the right of the sample statistic if the test is on the right. We find the p-value when we go to our calculator and we open up the z-test function, and we put in a series of numbers, one of which is the population standard deviation. When you don't have the population standard deviation, you're going to use the t-distribution, and the function on the calculator is called the t-test, which is number 2 right below z-test in the same menu. We find the p-value using using the t-test on the calculator when we are not given a population standard deviation and we're given the sample standard deviation instead. So whenever you don't have the population standard deviation, you're going to use the t-test in a hypothesis test involving a population mean. This includes an example that only provides you with raw data. When you have only raw data, raw sample data, you don't have the population standard deviation. You have sample data only, and from that sample data you can deduce the sample mean and the sample standard deviation. So again, a problem that doesn't provide you with the population standard deviation but provides you with the sample standard deviation. So we're going to go through 3 examples, 3 hypothesis tests, going through the entire procedure from beginning to end.